Hi students, let's look at this question here, which is on DRV taken from the year 2018, Diamond High Paper 2 question 10. The discrete random variable x has a probability mass function given by this. So you start with 1, 2 to n here, and where x is 1 to n, right? Show that a is 2. Great. So the probability is 0 otherwise. So you start with 1 and you end with n. In other words, you know that if you were to sum px equals to 1 plus px equals to 2 all the way to px equals to n, this whole thing here will give you the probability of 1. Okay, so you are actually essentially looking at a1. So if you substitute 1 in, then it will be n over n plus 1. Okay, plus a2, then this will be n plus 1, a3, n plus 1, and all the way to the last one, which is n plus 1 equals to 1. Okay, so this is how you see it. Once this is done, just factorize the n plus 1 out, because they are just considered as 1 plus 2 plus 3 all the way to plus n. Okay, this is an AP. This is an AP. So how do you find the sum of AP? The sum of AP is just the number of terms, okay, divided by 2 first plus last term. Okay, so just remember that that's the sum of AP. So this is a n plus 1, and that will be number of terms n over 2. This is 1 plus n equals to 1. So now we could actually just cancel this out, and that will be a over 2 equals to 1 and a equals to 2. Okay, so that's how you do the first part. So let's look at the second part. Find ex in terms of n. You may use this result here. So you're given this result. Let's see how you can do this. Ex in terms of n. So ex for part 2, we know that expectation of x, ex, right, will just be 1 multiplied by px equals to 1 plus 2 px equals, just write it down. Okay, if you can't write it down in syllabus notation, just write everything down first, then we'll try and figure out the pattern there. So px equals to n. This is what we have, right? So in other words, what we have here is actually the sum where our r is 1 and we end with n here, or rather is it like r, then this would just be px equals to r, correct? So px equals to r, we were told that it follows this form. So px equals to r, okay, px equals to r. If this is r, you just need to sub this as r, right? So this is the r. These are constants, okay? A, n plus 1 and plus 2, these are constants. So we can just write this. If you're not comfortable with r, you can use the x here. It's fine as well. So this is x, and this will become x here. This becomes x, okay? So what I'm going to do is actually just n, x equals to 1, and this is x, 2x over n plus 1. And I'm just going to bring out the constant out, so it's 2n plus 1, x equals to x squared. Okay, so summation of x squared will just be this formula here. We are using this formula, n over 6. So if this is x, then this actually just be the same formula here. So it's n. This will be just 2 over n plus 1. This will just be n over 6, n plus 1 to n plus 1. Okay, so cancel it out. 1/3. So we left with 1/3 to n plus 1. Right, so that's how we do this part here. So let's look at part 3. Two players P1 and P2 play a game with n plus 1 tokens labeled 1 to n plus 1. Each player randomly picks one token without replacement, and player who picks the token with the smaller number loses. So the amount of money lost by the losing player in dollars will be the number of winning tokens. For example, if P1 and P2 picks the tokens labeled 5 and 3, P2 loses $5 to P1. Okay, that's pretty okay. So part 3, explain what the probability of P2 losing a game is 0.5. Now if the game is 50% chance of losing, meaning you have 50% chance of winning as well, it's actually, the game is fair. Okay, so if it's essentially, okay, let's try and understand this from perspective, right? So this case here, if you have a token from 1 to 1, 2, 3, all the way to n and n plus 1. Okay, the number of ways to distribute to P1 and P2 is actually just n plus 1. Choose 2, you just need to choose 2 times 2 factorial. Okay, now if you take two numbers, one of it will be bigger and the other will be smaller. Definitely one will be bigger, one will be smaller, right? So the proportion of P2 taking the smaller number is actually half, because there is equal chance. There are only 2 outcomes, right? When you choose the number, so there are only 2 outcomes. That is, the token is 2 outcomes. One of the token will be larger. One of the token is larger, the other smaller. Okay, there are only 2 outcomes. Okay, so anyway, so means the P losing game would just be m plus 1 over 2, m plus 1 choose 2, you m plus 1 choose 2 times 2 times half, because half of the time he will take a smaller number, and then plus 1 choose 2 times 2 factorial. So this will just be half. Okay, in other words, game is fair. Okay, that's how you can explain. This game is definitely fair. If you have 50% chance of losing, you definitely have 50% chance of winning it. Alright, so this is how you understand this part here. Let's look at part 4. Given that P2 loses, find the probability that P2 loses m plus 1 in terms of m and n, and m such that m what is this going on? M is m. Okay, can sure. Let's see how we can do this. This part here, so given that he lost, I'm just gonna try and see whether given that he lost, the required probability, okay, P2 loses m plus 1. Okay, m plus 1, where m plus $1, given that P2 loses. Now this is pretty okay. So this one will be P2 loses. He will only lose m plus 1 when P1 takes m plus 1, right? So intersect. So this is pretty okay. P1 loses given. So this is P1 loses m plus 1 given P2 loses. P2 loses would just be obviously half. If P2 loses m plus 1, meaning P1 selects m plus 1, right? The token m plus 1 selects the token, because selects the token m plus 1, and P2 selects token m or lesser, number less than m plus 1. Okay, so this is important. I think for the one below is quite okay, because P2 loses, we know that it's a fair game, so this case it will just be half. Okay, now if P1 selects the token m plus 1, this is the picks m plus 1, there's only one which is m plus 1. So there's only one token which is m plus 1. Okay, there's only one. The token out of all the piles in it, right? There's only one token which is m plus 1. Then there are how many tokens which are lesser than n plus 1, that will be, the next one will be, and this is without replacement, right? So 1 over n plus 1 times m. There are m amount of tokens which are lesser than n plus 1, because if you have you need a token which is less than n plus 1, you have actually m of them. Okay, so this is how you do this. Then what we do is you just say this is 2m over n plus 1. There you go. So that's how you do this question here. Okay, let's look at the last part using the result in part 1. When P2 loses a game, find the amount that he's expected to lose in terms of n. Okay, let's see how we can do this. Now this is the probability that he loses n plus 1 when P2 loses. Okay, so the question now is, how do you find the expected value there? You have got P here. This would just be part 4. The probability of the expectation of P2 loses n plus 1, okay, when P2 loses. Okay, what we can do is actually, the expectation would just be summation of the running values. So basically m multiplied by P, whatever this case is, meaning to say, let's say this is m. Okay, this whole thing here is m, this probability here. So this function here we already found in the second part, which is this part here, m. Okay, so let m be the amount where you run. So you just keep putting m, or essentially this is actually n plus 1, right? So you're losing n plus 1. So actually what you need to do is, this is n plus 1. So it just be summation of n plus 1 probability of when you lose n plus 1, right? n plus 1. Okay. Let L be the amount he loses. Let L be the amount he lost. Okay. In a game. P2. P2 loss. If he loses a game. Okay, so this is the amount he lost. This is a bit confusing, but I'll just try and explain this part here. You know that this m running number will be from 1 to n, okay, because you are told here where m is between 1 to n, right? If he loses, it will be 1 to n. So this is actually a weighted average here. So if he loses n plus 1, this probability you just multiply and so on. So what we're going to do is, from the second part here just now, what we did was n plus 1. This probability where he loses from the second part was just 2m over, this is 2m over n plus 1. Okay, so from the first part, this one looks something similar. You actually have got this. If you were to multiply this in, you can actually multiply this term in here just slowly. This is 2m squared over n plus 1 plus 2m n plus 1. You see that? Okay, this is similar to the first part, which is actually the first two parts. One is the one with the square, which is this part here, this x squared here. Alright, and the other one here is the one without the square here, which is this part here. So from 2, you know that x squared here, px x squared here. Alright, which you're using this, right? So this cuts. Just do this. Plus n. Okay, maybe the constant can bring it up, and then I will just do it on this. Okay, this is from 2. You know that this is just 1/3. 2n plus 1. Okay, this from 1. From 1, you know that this is just, is it 1? It's just 1, right? Yeah, there you go. It's just 1 here. So you essentially just found the sum of this, which is 2. So this is just 1. Right, because from 1 here you can see that this case here is just summation of n 1 to n. You see this is n1 x1 to n, ax n plus 1 is, which is 2. A is 2, right? A is 2. This will give us 1. Okay? So this is from 1. We get this as 1. There you go. So once this is done, you just need to expand this. This will be 2 third n plus 4 third. That's how I do this question here proficiently. Not fun. I think it's not easy at all. But just try and understand this. Any question, please let me know and I'll see you in the next question.